Yes, students, we will be doing the relative velocity once again. Last time we saw about the graphical method. We saw about two bodies going in the same velocity, and one is the positive relative velocity and negative relative velocity, all these things we saw. Now we are going to see about the analytical method. So analytical method is somewhat the same way, but it is without a graph. We will be doing a formula based on this. Consider two bodies starting from the same point, but one body is going with the velocity VA and next body going with the velocity VB. We are intending to find the relative velocity of B with respect to A. We want to find out the relative velocity of B with respect to A. So if this is the way, if with respect to A we wanted to find out the velocity of B, then what the method says is try to impose equal and opposite velocity of VA on both A and B. I am again repeating my point. In order to find out the relative velocity of B with respect to A, impose equal and opposite velocity of VA on both A and B in the same direction, in the opposite direction. So it is here, it is going to be minus VA, and here again we are going to put this one, it's going to be minus VA, such that the body VA is brought to rest. It is just an assumption we are trying to take. When both the bodies we are trying to, it is going to in the same direction, in the same track with a different velocity, and we want to find out the relative velocity of B with respect to A. So impose equal and opposite velocity of VA on both A and B. So A we imposed here, B also we have imposed here, such that the body A is brought to rest. Then the resultant here will be giving the relative velocity of B with respect to A. So look at this one. Here we already imposed. Now look at the after imposed, what is the way in which it will be there. This is at rest. A is at rest. And the body B, how it is, now here it's going to be less because VB minus VA, so it will be VB minus VA. You will get a less amount of velocity. This is going to be the relative velocity of B with respect to A. I will once again explain this method, analytical method. When two bodies are going in the same direction and we want to find out the relative velocity of B with respect to A, impose equal and opposite velocity of A on both A and B, such that the body A is brought to rest. When the body A is brought to rest, the resultant velocity of B will give the relative velocity of B with respect to A, that is VB minus VA. So that's the method which is we are seeing when the two bodies are moving in the same direction. Same thing can be applied across. Same method can be applied across even when the body is moving in the opposite direction. So consider here VA is moving in this direction and VB is moving in this direction. So both the bodies, this is A and this is B, going in the opposite direction here. Now same method continues. Impose equal and opposite velocity of VA on both A and B. If we have to find out the relative velocity of B with respect to A, so VBA is equal to impose equal and opposite velocity of A on both A and B. So it becomes, this is the direction of opposite, this is the direction minus VA. Same direction we need to impose here also. Same direction, same value we imposed here also on both A and B. Okay, such that, so what happens here? This is brought to rest. So finally you will find this has been brought to rest. A is at rest. So what is B is going to be equal to? B will become equal to a very high velocity because it is VB minus of minus VA. VB minus of minus VA, which is going to be equal to VB plus VA. So you get here VB plus VA, you will get here the velocities will be added together. The velocities will be added together if it is like this. Okay, so impose equal and opposite velocity of A on both A and B such that A is brought to rest. The resultant velocity of B will give the relative velocity of A with respect to B here. So it is minus of minus VA will become plus. So both the velocities are added. In opposite direction, velocities are added. In the same direction, velocities are subtracted. So that is the kind of a straight conclusion we can have in always in relative velocity. Same direction, velocities are subtracted. Opposite direction, velocities are added. We will consider the next instance where when two bodies are moving into different direction making an angle theta. Maybe it could be like this also. A is going like this and B is going like this in this direction. But we can extend them. We can extend them like this and make an angle theta, or we can bring this one over here. We can bring this one parallelly over here with the same magnitude, with the same direction, with the angle theta, we can bring it. So that's the way we have brought this particular diagram here. VA is in this direction, VB is in this direction, making an angle theta here. Same rule applies here also. What is the rule? If you want to find out the relative velocity of B with respect to A, VBA if you want to find out, impose equal and opposite velocity of A on both A and B such that VA is brought to rest. So the first thing is bring VA to rest. Put this person at rest. So minus VA. Now this is brought to rest now. Again, we need to impose for this one also. So if you want to impose equal and opposite velocity of VA on B, which direction we will put? Some of you might say we need to put in this direction. But it is not that way direction, because you need to put equal and opposite of VA. It is in this direction. So this direction, it has to be coming two times, one for VA, next time for BB. Don't think it has to come this direction. Why it cannot come in this direction? Because equal and opposite of VA. What is the opposite of VA? This direction. This direction has to be put two times, one for VA and one for VB. So one you have already put, the next time for VB also put in the same place itself. So it is two times we have put here. On both this one is for VA and next one is for VB. So for VA, it is also already brought to rest. And now for VB, one VA is still remaining here. So that will give a resultant here. The resultant will be brought somewhere here. This resultant will be called as VBA. So VBA will be the resultant here. This angle will make it as 180 minus theta. So the angle 180 minus theta is going to be the angle between these two, V minus VA and VB, and angle minus here. This is the resultant. This resultant can be found out. So when you need to write, you can write this one. Consider, as I am telling, you can write in your notebook, consider two bodies VA and VB going in two different directions with velocity VA and VB with an angle theta. To find the relative velocity of B with respect to A, impose equal and opposite velocity of VA on both A and B such that VA is brought to rest. The resultant of the velocities of minus VA and VB gives the relative velocity along the diagonal of the parallelogram as VBA. So we know the formula here. We know what is the formula of the resultant here. We have studied here resultant is equal to under root of A square plus B square plus 2AB cos theta. Here what is A? So A is going to be equal to, and B is going to be equal to, what is theta is going to be equal to? We need to see and continue. So here A is going to be equal to VB, B is VA, and what is theta? Theta is going to be equal to 180 minus theta. That is the angle which you get here. VB is A and B is going to be VA and 180 minus theta. So this is kind of a basic thing to help us to write the formula here, which is going to be equal to here square root of VA square plus VB square plus 2 VA VB cos 180 minus theta, which is equal to VA square plus VB square minus 2 into VA VB cos theta. What happens? Cos 180 minus theta is minus cos theta. So we have changed this value. So within bracket you can write cos 180 minus theta equal to minus cos theta. Using that formula, we have made this value as VBA. The next one is, we can make the next value as what is the angle, what is the direction. The direction will come in this direction here, which is called as beta, maybe alpha also can say, we can take it as beta here. Tan beta is equal to, we know the formula here, usually we know what is tan alpha is going to be equal to, tan alpha tan beta is going to be equal to B sin theta upon A plus B cos theta. We know what is B, what is A, which is all written here, so you can straight away apply here. It is going to be VB sin theta upon VB, it is called VA. VA sin theta, because B is here, VA sin theta, 1 VB plus VA cos theta. Now this is not theta going to be here, this is going to be cos 180 minus sin 180 minus theta and 180 minus theta here. Putting it further, tan beta is going to be equal to VA sin theta upon VB minus VA cos theta. You will get this as an answer. Why there is a minus? Cos 180 minus theta is equal to minus cos theta. You put here there. Sin 180 minus theta is going to be equal to plus sin theta. So you get the same value here. So you get this direction here. Here we can continue to do the two cases which could be possibly coming when theta is equal to 0 degrees and theta is equal to 90 degrees or 180 degrees. These all these cases you can find out when theta is going to be equal to 0 degrees. That is, VA is going in same direction of VB. VA and VB are going in the same direction. Theta is going to be equal to 0 degrees. So how this will be now? So how this will be? It's going to be equal to VBA is equal to under root of VA square plus VB square minus 2VA VB cos 0. Cos 0 is 1. So you get cos 0 is going to be equal to 1. That is going to be equal to VA square plus VB square minus 2VAB VB, which will be equal to VA minus VB. So it's going to be equal to VB minus VA will be the value here, right? And VBA, we know this value already because this is the way in which the relative velocity will happen when it is going in the same direction. Alright, so the next part is when theta is going to be equal to 180 degrees. When theta is going to be equal to 180 degrees, VA is opposite to VB. So VBA is equal to under root of VA square plus VB square minus 2VA VB cos 180. So cos 180 is minus 1, minus 1, minus 1, it will become plus. So it is going to be equal to VA square plus VB square plus 2VA VB. That will become equal to VB plus VA. That is VBA. So when you are going in the opposite direction, it gets added. We already know this one. We have got the same formula here. If it travels in the 90 degrees, then you can find out it's going to be a different value here. Similarly, you can see the direction also. So tan beta is going to be equal to, so tan beta, when it is 0 degrees, then it's going to be 0 degrees here, and here tan beta again will be 0 degrees here. So we'll be able to see how the direction changes in the whole thing. Now we are going to see two important examples of relative velocity. The first example is when a man is traveling in the rain and the rain is slashing against him, and rain has its own direction because wind blows along the rain, and the man is also traveling. So let us consider Vm is the velocity of the man. He is going in this direction here, and Vr is the rain is pouring down straight. But remember, since he is already going, in which direction he will be experiencing the rain? So that becomes a relative velocity of the rain with respect to man, because he is going to experience the rain not just pouring down. He is not at rest. He is already moving. Since he is moving, he will have a relative velocity of rain with respect to this man. So we are going to see how it works. Now, first of all, we need to consider the same thing when this rain is going down. That is called VR. It's all going down. Let us use the same principle here. In order to find out the relative velocity of rain with respect to the man, try to impose equal and opposite velocity of the man on both the man as well as the rain, such that the man will be brought to rest. First of all, bring the man to rest. So we are going to put an equal and opposite velocity of the man minus Vm is been put here one time, so that these two will be cancelled out. Again, the next one is minus Vm. We need to put for Vr. So that is again minus Vm. Two times we need to put, we already seen this one. So impose equal and opposite velocity of the man on both this man and as well as the rain. So two times. So it's that the man is brought to rest. Now only two things are there. The rain is there and this is there. So one minus Vm and Vr. Because of this, you will get the resultant somewhere here. You will get a resultant here as V capital R, that is the relative velocity of the rain, with an angle here as theta. So he will be experiencing the rain in this direction here, with that angle here. If he has to hold an umbrella, he has to hold an umbrella like this, in this direction, so that he will not get wet. The velocity of the rain will be coming relatively because of his motion in this direction with theta with respect to the perpendicular, and this is the relative velocity here. Now we can find out what will be the rest of the values which is going to be here. So how do we write this one? Write down clearly. Consider Vm is the velocity of the man. As the rain falls perpendicular to him with the velocity Vr, the relative velocity of the rain with respect to man is given as Vr. To find the relative velocity, impose equal and opposite velocity of the man on both the man and the rain, such that the man is brought to rest. So the resultant of minus Vm and Vr gives the relative velocity of the rain with respect to man, capital Vr. So Vr is going to be equal to under root of Vr square plus Vm square. So that is going to be the value, because it's going to be a 90-degree angle here in between them. And also we can see tan theta is going to be equal to, what is tan theta? You can see here as minus Vm upon Vr. We need not put minus. We already know it is coming in opposite direction. You can go in the opposite direction here, and this will give the direction of the rain with respect to the perpendicular. So these things will cover up and give us in detail. Theta also you could be equal to tan inverse of Vm upon Vr. So that will give you the angle here. We are going to consider the next example here. The next example is a swimmer who is crossing a river. When a swimmer is crossing a river, which is already flowing with a velocity of u. Now his thing is, he is right here at A and he has to go and reach here at B, or he has to reach anywhere in this bank. The distance between the two banks, it is given as B. U is the velocity of the river. Now his velocity, the maximum velocity he can swim is only V. It depends upon which direction he is to take. He can go straight also, so that he can go and reach in the opposite direction. He can take this direction also. It depends. It looks to us like when the river is already flowing, when the river is on the flow, it is better he takes this direction so that he can eventually reach here. Why he is taking V in this direction? Because that will be the relative velocity he is taking, the resultant velocity he is taking, so that he can finally reach here. Had it been he goes straight with his own velocity, he will reach in this direction as a resultant. That will be the relative velocity of the man and the river together. So his velocity is only this much. The velocity of the river is u. Put together you will get a resultant of a velocity here. So let us consider he is putting a velocity v with an angle theta here. If the angle is theta here, there are two components which could be given here, the perpendicular component and the horizontal component. The horizontal component will be called as v cos theta, and the perpendicular component can be called as v sin theta. These are the two components which will be always there, and he is trying to move in this direction. So together, total velocity in the direction of the river, total velocity in the direction of river is equal to u plus v cos theta. So that's what it's happening here. Both of the velocity is going together. And next one is along the flow. This can write it as along the flow. The next one is the velocity along the perpendicular. Velocity along the perpendicular is going to be equal to v sin theta. So two components we have taken and two velocities already we have done. This is the horizontal velocity, that is u plus v cos theta. Vertical velocity is v sin theta. Now there are two cases which will emerge out here. Case 1 is going to be equal to cross the river in minimum time. If you want to cross the river in a very shortest time, that is called this first case. The second case will be to cross the river in minimum distance. One is minimum time, next is minimum distance.